Okay, so just to give you a recap where we were last year, we are doing a calibration of a microscopic model for buses, and we did also already the literature review. We checked the different models. Last year we were selecting the data collection technique, and you gave me some advice, and I'll tell you later what happened. And then finally we got a way of going around it and solving our problem, and now we already did some data collection, and we already analyzed some data, okay? But there is still more to do. Just to recap, we were thinking of different models. Last year I presented this to you, and we sort of demonstrated that the Gibbs model, which is a sort of very well established car following, in this case, or vehicle following, model would fit to our work, because it deals very well with several buses running one after the other. So what I reported to you last year is that we were doing this in a way almost like manually, and here you can see the bus moving, and you can see the markings on the film, right? Each marking every so many meters, and as the buses would pass there, we would stop and freeze and get the data, and that was a very tiring way of collecting data. And then several of you came to me and say, how about if you contact these people or that people at our university and see what we can get? And I should report back to you that we did all those contacts, and those people even put us in contact with other people, so that was very nice, but we ended nowhere. Okay. and that was the very unlucky thing. I mean, I went to some image recognition people working at my university there, and the guy said, oh, you know what, we can do a software for you, but that will take a year, and that will cost X or whatever. So we didn't like very much. So nothing like looking outside the box. Most luckily, we got a student from the electric engineering sector, and he started working with us, and on a different project on freeway traffic, and he had similar problems, and he said, why don't we go to sports? So we went to sports, and we just downloaded an open source code that takes 33 informations per second, because this is like athletes move. So you select whatever you want, a foot or an arm or a piece, and then it follows. So it's great. Okay. So now we were struggling in how to connect this to the movement of vehicles, and then as Dario was saying before, that we were not talking about BRTs in the early days, but I did my PhD on something called busways in the early 80s, and I had to use time-lapse photography. I don't know if you ever got involved with that. Very expensive 8mm stuff, filming real things, and 2 frames per second. Now we have 33 frames per second. And so we went back to the 1970s papers that does the parallaxis correction. So we used that, and it was very successful. So it was great to associate earlier time-lapse stuff with very modern things. And so just to give you an idea, I mean, we have the plan from the film and the plan from the road, and that's the way you convert things. So now we connected the two things, and we corrected the data, and finally we have data. That's the good thing. So as I don't have much time here, I don't want to get into the details of the model. So we structured the whole thing. We did already some filming. I don't want to go through the equations also, but just let you know that this is the Gibbs model. But this is not the Gibbs, but this is great for accelerating vehicles. But then we did a car following, and this is in fact a vehicle following adapted for buses, for a bus to stop, but a bus alone to stop. So we started with this, bus alone starting and bus alone stopping, and we collected the data from the film. We translated it using the parallaxis correction. So we got to the real and to the model. And then based on the acceleration model, so we got parameters. Just back a bit, we got some parameters for maximum acceleration, desired speed. So we are on the way. We are happy the way it's going. If we get the data, and certainly we have more points, but just a few here to show you. I mean, we have We have time and speed and acceleration and distance, so it's working properly. You can even see the driver changing the shifts, so it's going nicely. Okay. So we calibrate the things, and we certainly have to adjust, but we are on the way. And also we're looking at how loaded the vehicle is and the effect of how loaded the vehicle is on the acceleration of the vehicle and the time it takes to reach the desired speed that usually is around 60 kilometers per hour. By the way, we're using data from Curitiba. So what we did so far is we did filming in Curitiba and we got data from Curitiba. The problem in Curitiba is that we don't have bus bunching there, so it's or seldomly we have bus bunching because of the 1 minute headway and some corrections there they do, and the drivers already know how to. They use some heuristics there to cross the red and so on. They know a few things, so it's little bunching, not enough for the case we need here. Okay, so we calibrated deceleration also, and the model fits very well. So we are able now to get our buses running as we were before, also already in the model, and stop it. Okay, not big deal here, just the parameters which are important. Now the fact that I need you when I said at the beginning is I'd like to know if other people would be willing to do some filming for us, because now we don't have to paint anymore on the floor, right? Because in the previous day that would be very difficult. I mean, ask somebody to do, can you film something? Oh, by the way, can you paint a few things on the street? I guess, which is something, you know, not very nice to do. Now we don't need this painting anymore. All we need is 4 references point, measure on the street, and a good setting for filming, and we need bus bunching, okay? I mean, certainly Santiago is a good case. And I'd like to have other good cases for that so that we could process all the data now, because we have now a very good way of processing data. Okay, so basically this is my presentation. I want to take longer. Okay.
Thank you very much, Lenny. Questions regarding this issue? We're moving from the strategic to the very tactical in this
What
case.
kind of scenarios do you have in mind once you're calibrated and up?
Good. Very good, Sam. By the way, I forgot to mention, this afternoon at 2 something after lunch here, there is a bus operation session, poster session at TRB at Hilton International Center, I think, right? Where the posters are. And we have a poster there, and there we show the scenarios we use so far for using. We are exploring the limiting capacity so far of a single no overtaking bus lane. And the magic result is around 15,000, but with a lot of bunching and wall and bus wall effects and everything, but we're exploring the maximum. I mean, this is what we did so far. And we're using also the simulator, and Juan Carlos will probably mention, and Felipe Delgado probably also, I don't know, it's not the Felipe Delgado thesis, but it's the application, it's the further application of Felipe, probably you will mention. We use that in Chile in collaboration to test holding techniques, right? And Ricardo also supervises. So we're using the model to explore a few things. We're doing collaboration with the university to test new ways of controlling BRTs.
What is the work that comes ahead?
Oh, and there is also the challenge of simulating real Wagner. Where is Wagner?
Just left.
Is left. Okay, Wagner is proposing this system in real for 60,000 passengers per hour per direction, and we're simulating that. But I think that the problem won't be the buses there, but it will be people arriving at stations and moving in stations. It's likely to be the problem. And we cannot do, we don't deal with people, and I'm after software for that, but so far I haven't come across any fantastic software for people moving at BRT stations, actually, because we're talking about very narrow environment and people have to move from one to the other. Sometimes I've seen some presentations on metro things, but then it's different, you know, much larger space and so on.
What's ahead in the research agenda, Tony?
Well, in the research agenda, I'd like to have, again, more people volunteering to do some filming so that we can do the next steps, which would be calibrate and try to validate using information from other places.
You mentioned...
In this bit, right, not the whole simulation thing. I mean, this is just one specific thing for the model.
For the bus following model.
For the bus following model.
You mentioned 15,000 as a magic number.
For one lane, no overtake.
What kind of buses? What kind of vehicles?
150, 160 passengers per bus, articulated buses.
With
in
the,
that case.
with the normal acceleration, deceleration?
Yes.
What about platooning strategies? Are you going to look at those at all?
Not in this case. I mean, that was my PhD actually in the early 80s. But the thing with platooning is that at some stage with convoying, at least in Brazil, we explored this very well in Porto Alegre. We took that to the limit and then beyond the limit, I would say. And then the end result of that, after, you know, you can think of the corridor, but the end result is a lot of buses in the city center. And a lot of very long, this effect of the wall, moving very slow. So we are having now speeds around 7 to 8 kilometers per hour in Porto Alegre, which is a disaster.
Well, but I think one of the parameters that goes into the simulation is what if you have multiple lines and have to form up platoons, and they're made and unmade as buses may leave at individual entry and exit points. It's a completely different situation than if you have a service plan where there's basically one route, perhaps with turnbacks, like in Istanbul, where you have a platoon that's eminently formable, which is 2, but you know, so there's a lot of parameters that enter in. The work we did was many routes.
Yeah, certainly there is a lot of things to explore further on with the modeling, but so far we just explore one corridor using in changing the number of bus bays. So in a way, platoon of 2 buses, as you said.
We were with Ricardo in Istanbul in October, and I think in that particular scenario where you have a very long corridor with a single line, with huge stations, with frequencies of 1 bus every 15 to 20 seconds, it's so obvious that the bottleneck is becoming the station, and that what you have to do, I mean, it's evident that what you have to do is to perform in the way you mentioned, because one of the bad things of platooning is that you lose frequency. But if you're moving from 1 bus every 15 seconds to 1 bus every minute, it's the same thing. And on the other hand, you'll be able to increase capacity by using the bus stops more efficiently. But I totally agree. I mean, I don't think that's the right tool for any system. If you have probably very different lines coming up to different directions, it's senseless. But in a place where the one you have mentioned in Istanbul, it's exactly what I think we would have to do. And it's been very interesting to, and also the other thing is that maybe you can, I don't know when did you try it, but today we have much more vehicle-to-vehicle information technologies where you can address all the elements associated to closing doors, starting, accelerating. That's certainly something
someone else's control.
Totally, we should explore.
There is a great GM report from the 60s on bus platooning. They did every experiment, filmed the whole thing, and the big question about bus platooning in high speed, which is something that we may end up like Istanbul and like in Rio now, because there will be no traffic lights. The big question is how close the buses will be traveling at, say, at 80 kilometers per hour. I mean, they shouldn't be as close as drivers usually drive. Because then we may have terrible problems. I can foresee a disaster in Istanbul, actually. That is bound to happen.
Sorry? I think that's something that we should definitely...
Under manual control, you're right, but
there should be
there's at least 3 manufacturers. I think it's actually 4 now. Toyota, Bosch, Google, and Volvo that have automated car operation that's likely to go into for sale in the next 3 years. So keeping 2 buses together at a 4-minute headway, I don't think when you have...
And I'm not thinking of the 4 buses running at 1 meter distance.
No.
I'm just saying, okay, it's done, start, and that's it. I mean, not making it dangerous.
That's where the coordination...
but the way they drive today, if you look at the acceleration rates and safety, it's not a safe operation. I mean, if something happens in the platoon, they are bound to hit. So that's why automation gets an important role.
Fine. Brendan?
Just briefly, because I think it's coming up in another presentation later. I think a fresh approach needs to be taken to operations management. The whole concept of your operations management within BRT. And I don't particularly mean yours, but generally speaking, it's an area that we've not explored enough, where quite often it's about continuing the forms of operation that have been done in the past over conventional buses. And maybe there's one set of operations management approach that is appropriate to a high level of automation, the other where there's quite high level of manual. but it has a big implication for the organization structure, who's doing what at stations. To a certain extent, you can design and plan for it, but you can't just think it's, and I don't think you do, but you can't just assume that you've designed it well and then just throw it out there every morning and hope that it works. So there's got to be the planning side, the technology side, and then the daily, very fine management side. And I think it's a new area, or an area that needs to be revisited with new concepts.
I agree.
So any volunteers to help me?
If you need bus launching, you should come to Cali.
Okay.
And we're happy to give you all the data that you need.
Let's see, all I need is filming actually.
Yeah, yeah.
Okay. Thanks very much.
I'll do that.